So hello everyone. So today's topic is three-dimensional geometry. Three-dimensional geometry. So we already know about number line, in which we plot a singular point, like this is a number line, and if we have to plot plus 3 units, then we will count. This is a 0 point, then this is 1, 2, and 3. So this is a point 3 on the number line. And if we want to plot minus 3, we will go backwards from 0, that is minus 1, minus 2, minus 3. So this is a point of minus 3. Second is, we know how to plot a pair of points, such as suppose 3 comma 2 in a Cartesian coordinate system. This is y-axis and this is x-axis. So here x is 3 and y is 2. So we will go 3 units along x-axis and 2 units along y-axis. So this is a required point 3 comma 2. Similarly, if we want to plot minus 3 comma 2, then we will go along negative x-axis 3 units and 2 units along positive y-axis. So this is a minus 3 comma 2, where these lines are coordinate axes. These lines are coordinate axes. But in actual life, we need 3 intersecting perpendicular planes to locate a position of a plane. In practical life, we need 3 intersecting perpendicular planes to locate position of a point. So we have coordinate axis and coordinate planes in three-dimensional space. In three-dimensional space. So what are coordinate axes? What are coordinate axes? Let's say there are 3 planes which intersect at 90 degree. Let there be 3 planes intersect at 90 degree. That is, if this is a plane and this is its geometrical axis, and if there is another plane, that is so this is first plane, and this is second plane, and a third plane will be so this is a third plane, and let this axis be z axis, and this is y-axis, and this is x-axis. So when these planes intersect along, and this point be O point. So when these planes when planes intersect along x dash, along x dash. So we have x, and this is O, and this is x dash. So x dash is nothing, it is a negative axis, is equal to negative x-axis. Similarly, we have z-axis, this is positive z-axis, and this is negative z-axis, that is z dash. And along y, this is y, and this is y dash, negative y-axis, and this is negative z-axis. So when these planes intersect along x dash, and y dash, and z dash, then the lines of intersection are called x, y, and z axis. Then the lines of intersection are called x, y, and z axis. That is, these solid lines are intersecting lines. And this is these are planes, and because these planes are perpendicular to each other, these planes are perpendicular to each other, therefore these lines are and these lines are coordinate axis is known as rectangular coordinate system. Therefore these lines are coordinate axis and is known as rectangular coordinate system. So what are coordinate planes? So what are coordinate planes? So the planes x o y, the planes x o y, y o z, and z o x are coordinate planes. So in the above diagram we can so this is the x o y plane, x o y plane, and this is a z o y plane, z o y plane, and this is x o z plane, x o z plane. So we can show it here. So this is z axis, positive z axis, and y axis, and x axis, and three axes are perpendicular to each other. So this plane is known as, this is z o y plane, and this is X O Y plane. This is center O, and this is X O Z plane, and these are coordinate planes. So and when these coordinate planes divide the space into 8 parts, then they are known as octants. Divide the space into 8 parts, then they are known as octants. So that is, if we have z axis, x axis, and y axis, so this is a first octant. So this is a first octant, X O Y Z, first octant. That is, we have 8 octants. So this is z axis, this is point O, this is negative z axis, z dash, and this is y axis, negative y axis, x axis, and negative x axis, x dash. So this is first octant. Similarly, we have on this side second octant, and below this plane, this is x dash o dash plane. Below this plane, we have another third octant, and likewise we have 8 octants. So if this is positive z axis, and this is positive y axis, and this is negative x axis. So we have, so this is x dash o y z octant. So likewise, there are total number of 8 octants. There are total number of 8 octants. So how to plot a point in a 3-dimensional space? How to plot a point in 3-dimensional space? So let there be any point P in XYZ octant, XYZ octant, that is, this is a rectangular coordinate system, Z, Y, and X. So we have point P whose coordinates are X, Y, and Z. So first step is draw perpendicular PM on XY plane. So this is XY plane, XY plane. So we drop a perpendicular on XY plane. So this is perpendicular. Now second, draw perpendicular line perpendicular line to x-axis, that is ML, which is parallel to y-axis. So we will draw perpendicular line to from M to x-axis, which will be parallel to y-axis. So this is point L. And now OL be let OL be x, OL be x, this is x, and ML be y, this is y, and PM be z, this distance is z. So from here we can know the coordinates of point P as x comma y comma z are the coordinates of point P. So there is a second method to plot a point on three-dimensional space. Second method, so in this we draw three planes parallel to the coordinate planes meeting x, y, x axis, y axis, and z axis. We draw three planes parallel to the coordinate axis, coordinate planes passing through point P. So therefore first we make a rectangular coordinate system x, y, z, and then we plot point P. Then we make a parallel planes passing through point P. So this is a plane which is parallel to YOZ plane, and this is a plane which is parallel to XOY plane, and last this is a plane which is parallel to XOZ plane, and all these planes intersect at X, Y, and Z axis at point A, B, and C. So this plane, it is parallel to XOZ plane, and this plane is parallel to XOY plane, and last this plane is parallel to YOZ plane, and the intersecting points are the coordinates of point P. So this distance is x, and this distance is OC is y, and OB is z. So we have OA is equal to x, OB equal to z, and OC equal to y. So the points will have coordinates x comma y z comma z. The points will have coordinates wherever these parallel planes intersect the axis, intersect the x-axis, y-axis, and z-axis. So from above we have the points of P as x comma y comma z, because OA is equal to x, OB equal to z, and OC equal to y. So these are the two methods to plot the point. in any three-dimensional space. So next is, what is the distance between 2 points? What is the distance between 2 points? So the distance between, let there be 2 points. Let there be 2 points x1, y1, z1, and x2, comma y2, comma z2. So the distance between these points will be same as we have found in the coordinate system of two axes. So the distance between these points will be same as we have found out in coordinate system of two axes. That is, by distance formula, the distance between 2 points will be x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. So this is distance in 3D, and if we have distance in 2D, is equal to x2 minus x1 whole square plus y2 minus y1 whole square. So only difference is the third coordinate system, that is z-axis. So this was about how to find a distance in between 2 points in three-dimensional space. So next is, when are points collinear? When are points in three-dimensional space are collinear? So let's say we have 3 points x1, y1, z1, x2, y2, z2, x3, y3, z3, and let this point be A, B, C. And these points are collinear when these points are collinear, that is, lie on a same line, lie on a same line. Then distance between AB plus distance between BC plus distance between BC should be equal to distance between AC. So this condition should be should satisfy to have the points in, so that the points are collinear. So that is, distance between AB is x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square plus x3 minus x2 whole square plus y3 minus y2 whole square plus z3 minus z2 whole square should be equal to root of x3 minus x1 whole square plus y3 minus y1 whole square plus z3 minus z1 whole square. So next is section formula, which is same as we have discussed in straight line concept. So in two-dimensional geometry, we know how to find a point which divide the line segment in the ratio m/n. In the two-dimensional geometry, we know How to find a point which divide the line segment in the ratio m ratio n, in the ratio m ratio n. Similarly, the same method we will apply to find the point. Similarly, the same method we will apply to find a point p x comma y comma z which divide the line segment so let's say qr in the ratio m ratio n. So let qr be any line, qr be any line segment such that point q and r have coordinates x1 y1 z1 and point r has x2 y2 z2, and let the point be p x comma y comma z which divides the qr into m ratio n. So from section formula x p should be equal to mx2 plus nx1 divided by m plus n. Similarly, yp should be equal to my2 plus ny1 divided by m plus n, and zp is equal to mz2 plus nz1 divided by m plus n. So these are the coordinates of point P, xp, comma yp, comma zp. So next is a special case of section of this section formula. Special case when m is equal to n. So when m is equal to n, then point P will divide line segment into two halves. That is, point P will be the midpoint of the line segment QR. Point P will be the midpoint of the segment QR. That is, if this is a line segment Q R and Q is a x1 comma y1 comma z1 and R is x2 comma y2 comma z2, then point P will be at the mid half of the QR. So m is equal to n. M is equal to n. Therefore, coordinates of point P will be xp will be mx2 plus nx1 divided by m plus n, where m is equal to n. Therefore, x1 plus x2 by 2. Similarly, yp should be equal to y2 plus y1 by 2, and zp should be equal to z1 plus z2 by 2. Therefore, midpoint of coordinates of midpoint are x1 comma y comma x2 by 2 plus y1 plus y2 by 2 plus z1 plus z2 by 2. Next is how to find the coordinates of centroid of a triangle. How to find the coordinates of the centroid of the triangle whose vertices are x1, y1, z1 and x2, y2, z2 and x3, y3, z3. So suppose there is a triangle ABC whose A coordinates are x1, y1, z1 and B coordinates are x2, y2. So therefore, step 1 is find the coordinates of midpoint BC. Find the coordinates of midpoint of BC. So suppose there is a triangle ABC. So this is a midpoint, let this point be D, and we drop a median AD. This is a median which divides a line segment BC into two halves. So therefore the coordinates of point D will be xD is equal to x1 x2 plus x3 by 2 and yd should be equal to y2 plus y3 by 2 and zd is equal to z2 plus z3 by 2. So therefore now we have coordinates of point A as x1, y1, z1 and coordinates of point B as x2 plus x3 by 2, y2 plus y3 by 2 and z2 plus z3 by 2. So this is a median, and so step 2 is according to geometry centroid divide the median into in the ratio 2:1. According to geometry centroid divide median in the ratio 2:1. That is, this is a point, if this is a point of centroid, so this is 2:1. So this is point A and this is point D and this is centroid. So we have that is m is equal to 2 and n is equal to 1. So by using section formula we can find the coordinates of centroid. So Cx will be equal to max plus n dx is divided by m plus n, and Cy should be equal to may plus n dy divided by m plus n, and Cz is equal to maz plus n dz divided by m plus n. So therefore we have Cx is equal to m is 2 and ax is x1 plus n is 1 cross dx is x2 plus x3 divided by 2 divided by m plus n, which is 3. So it is equal to 2x1 plus x2 plus x1 by 2 divided by 3. Therefore we have 4x1 plus x2 plus x3 divided by 6. So I think I have done this wrong. So this is not ax. So this is wrong notation. So we have coordinates of point A are x1 comma y1 and z1, and coordinates of point D are x2 plus x3 by 2 and y2 plus y3 by 2 and z2 plus z3 by 2. So by section formula, coordinates of centroid will be x comma y comma z. Therefore x should be equal to m cross x2 plus x3, x coordinate of point D, plus n cross x coordinate of point A divided by m plus n. Therefore m is equal to 2 x2 plus x3 divided by 2 plus 1 cross x1 divided by 2 plus 1. So x is equal to x2 plus x3 plus x1 divided by 3. So therefore we have a x coordinate of centroid, which is x1 plus x2 divided by 3. Similarly, y coordinate will be y1 plus y2 plus y3 divided by 3, and z coordinate of centroid z2 plus z1 plus z3 divided by 3. So this was about introduction to three-dimensional geometry. So here we talk about section formula and how to find a distance between 2 points in three-dimensional space, and what are octants, and when are points collinear. And last, we have discussed how to find a centroid of a triangle whose vertices are uh, ABC, and which divides the line segment into ratio 2:1. So thank you.